Hello, my name is Ujin Cho, and today I'm going to talk about homogeneous and non-homogeneous semiconductors. And next one is the Ohm's law. Which one is this one? And finally, I'm going to talk about Hall effects. Which one is in, wait a minute, please. Here. Firstly, I'm going to talk about some EK diagram. EK diagram shows us some relationship between energy and wave vector. And we also talked about in last video. And here is this called indirect band gap. This picture shows, and this picture shows direct band gap. Oh, yeah. And also learn about some longitudinal direction and transversal direction. And we gonna express about some longitudinal effective mass in this symbol. It means M means mass, and this symbol means telluride. Telluride. And other two direction, which one is the transversal direction, like this one, called this M with orthogonal. And this express the transverse effective mass. The next one is some EK diagram with some hole, and this yellow line express some heavy hole, and pink line express light hole. And next one I'm gonna talk about is intrinsic semiconductor. Intrinsic semiconductor is like you may understand like some, yes, this is all stable, you can say, and there is some quasi-free electron. Quasi means some like also can express with semi, and there is a covalent bond electrons, and there is a hole and quasi-free electron. They are some like, yeah, they are related. As you know, silicon is in silicon are covalent bonding. So this covalent bond electron means that electrons, which one is electrons that needed to bonding each other with some silicon atoms. And for intrinsic semiconductor, uh, you can you can understand this it with this equation. Ni means carrier concentration in intrinsic semiconductor, and N0 and P0 means N0 means electron concentration, and P0 means some hole concentration. They are both are from intrinsic semiconductor. And unit of concentration is uh, centimeter, and this -3 is time. And you can also know about this equation, which is mass action law. It means that there is some uh, exact value of some carrier concentration, and uh, N and P is related to that. And next things I'm gonna talk about you is extrinsic semiconductor. Extrinsic semiconductor means like a doping semiconductor with some doping with another element, like yeah, this one. And there is, of course, like if there is P, there is one more electron in this element. So it is finally to These free electrons are in this N-type extrinsic semiconductor. Next one is P-type. P-type, and like this, as you see, there is some elements B. It has less only 3 electrons, so there is some hole. And next one I'm gonna talk about is impurities, and we mostly uh, gonna discuss about substitutional impurities. There is some things that we call donor, and it is for p-type dopants. Donor means atoms which donate electron to semiconductor, and acceptors, which use for n-type dopant, means atoms which accept electron from semiconductor. So this donor is for this p-type, and acceptor is for this n-type extrinsic semiconductor. And this picture is about some donor state and acceptor state in visualize. Which one? Yes, visualized. And next one I'm gonna talk about is some things about Ohm's law. As you know, Ohm's law is voltage equal current times resistance. So, and as you can see, current can express in this way. And as you know, there is, if the surface is bigger, and then current will go more. And current surface is smaller, current is smaller. You can express it in this equation, this relationship. And also we can express it with this resistivity law. So, current densities can express in Q, N, and mu, E. And this part means some how many electrons or how many hole. And this pink part means, in conclusion, like how fast it is, velocity of carrier. So we can understand about that equation, about this J. Current density means Q times N. How many charge are N, U times E, and how fast they are. And this can express some about carrier transport. And now I'm gonna talk about Hall effects. You should not some confused about Hall and this Hall, which means uh, some plus charge, plus charge in semiconductor, and this Hall. As you can see, and following the Fleming's right-hand law, you can understand these pictures, and you can get some equations about this one. So finally, we are gonna say about this is Hall effect can be used to give quite operation value for carrier concentration. So we can get some carrier concentration by this these equations, and we can also get some which type of that extrinsic semiconductor is by some polarity of VH. So this is what I talk about today, and thank you for watching my video.